Is that really why control systems go wrong? Okay. Out of control, why control systems go wrong and how to prevent failure. That's a publication of the United Kingdom's Health and Safety Executive. It is, very well known in the functional safety business. And I have used this chart in multiple presentations over the years. And what it represents is the percent of particular phase of the life cycle where things went wrong that resulted in eventually in a serious incident. 6% installation and commissioning, 20% modifications after commissioning, 15% operation and maintenance, 15% design and implementation, and this is the biggie that was a surprise to a lot of people when it was published, that the idea that where we were going wrong with process safety and related to instrumented protective functions was in specification. So if you take that pie chart, you can do the same thing against the safety life cycle, specification, design and implementation, and then you can break it down a little bit more to show the areas that we're interested in, hazard and risk analyses, then SIF selection, safety instrumented function, and safety integrity level determination. The SISFEL is what we used to and still do call the group that I am in. And then device selection, safety integrity level calculation. Again, that's a SISFEL function. And then, not to cut off half the life cycle, installation and commissioning, operation and maintenance, modification. I think if you had taken a survey of people before the HSE publication came out, this is where people would have said most of the incidents were caused. And I'll have a little bit more about that to say about that later in the talk. What really prompted me to want to do some of the research that led to this talk was what is known as the Streetlight Effect. You may be familiar with this little story of someone on their hands and knees, obviously looking for something. Along comes a police officer, asks the person, what are they doing? And they say, they're looking for the car keys that they dropped. Well, the officer wants to help, so he asks, where were you standing exactly when you dropped them? And the person replies, back up the street. Then why are you looking here? Because the light is better. Are we looking at just at the specification to the not to the exclusion, but more giving it more effort than we should? Because that's our business. That's what's right in, at least, my part of the business. That's right. What's right in front of me on my desk or on my computer screen is the SISFEL portions of the safety life cycle that I just identified. So that's the Streetlight Effect. When I was putting this talk together, I said, well, I'm familiar with the identification of the different incidents in the report, where they identified that specification is where they went wrong. But I said, well, I probably ought to go ahead and really read the report. And if I read the report is not as exclusive to the analysis of the various phases as I was assuming. They do say that poor hazard analysis of the equipment under control, inadequate assessment, systematic approach not used. These are all portions of the specification phase that when you lump everything together as specification, that's where I started to get worried if we were looking where the light was better. So this is the table from that report, and where they picked up 44 of the incidents that they reviewed were 44% were due to inadequate specification. And they said of those, 12 were inadequate functional requirement specification, and 32% were inadequate safety integrity requirement specification. Well, if you look at all of the incidents in the report, only 1/3 of the total number of incidents, which was 15 of the incidents in this case, is the total number, only 1/3 of those, or approximately 5, are related to incidents in the chemical or refinery industries. So do the causes of incidents in the process industries follow the distribution given in out of control? That was my premise in starting this. And there are lots of compilations of incidents in the process industries, and we'll give a list of references at the end of this presentation. But the granularity of the causes in these compilations is somewhat limited. In other words, just because a significant incident happened, very few cases do the reports, particularly the summary reports that you can find on multiple incidents, rarely do they give you the detail that you would need to say, was this specification related or not? Most of the major incidents involve a sequence of events. They have multiple causes related to organizations and other things. And they generate these large reports. And again, you may find something that says, well, specification of this control or safety function was inadequate. That's almost never the entire story. So I did go through, and this is, several of the reference lists, and I did look at 50 incidents in a particular period of time out of loss prevention in the process industries, which is a commonly cited book. And I was only able to identify 5 that were in the least bit instrument related based on the description that was given. And again, can you say from this, were these specification related? Possibly. There's just not enough detail to tell. So my initial premise that I could review the incidents and compare the results that I could get to the same distribution of incidents of causes in the HSE publication turned out to not be very practical. But what can we talk about? Well, here are some of the better known major incidents. I think everybody's probably heard about most of these. Of course, Pasadena in 1989 was the explosion at the Phillips 66 facility here in the Houston area that resulted in the death of Mary Kay O'Connor and eventually the founding of the Mary Kay O'Connor Process Safety Center. The one incident of all of these where you could say that specification, it sure sounds like specification was a good portion of the problem, was Buncefield. But essentially it was a tank overflowed in a fuel depot outside of London and generated a vapor cloud that eventually exploded. And reading the reports on the incident, if you look at it, it's like, boy, if this was the consequence Did they not recognize the potential consequence of overfilling a tank? Would it have not have made sense to have multiple independent, diverse technology level instruments and communication to the remote control center? So I would have to say, of the major incidents that most people are familiar with, bunch fill becomes the closest to being specification related. So where can things go wrong in specifications? Well, obviously in the hazard assessment, if you don't identify a hazard, if you don't identify an initiating event, if you don't accurately predict the potential consequence, if you give too much credit for your existing safeguards, well, then you're going, then you have missed something that will not be addressed in the rest of your project. Risk assessment, people tend to overestimate or underestimate initiating event frequency. We happen to be involved in a project right now I did some checking on just the other day, where we're actually doing some failure mode and effect analysis, trying to apply some Bayesian statistics to help a client identify a closer initiating event frequency to the true value than what you can get just out of looking at the reference books. Obviously, you can underestimate the consequence severity. Conditional modifiers and enabling conditions inappropriately applied to reduce the potential frequency. I borrowed this chart from the presentation I did a while back on functional safety assessments, and this is just, I put this together. It's not really a serious analysis, but one thing we run into frequently when people ask us to help them do safety integrity level determination of safety functions related to fired equipment is that they start out assuming that if the slightest bit of uncombusted fuel makes its way into the firebox, then you have a violent explosion that results in a fatality. And if you look at it, it's, that makes an awful lot of assumptions. So this just happens to be a specific instance that I've seen several times, and people come up with outrageous, what seems unnecessarily high safety integrity level requirements beyond that required by the standards to address this, when if they took a more hard-headed look at it, it would not necessarily occur with the frequency or the consequence that they assume. In the safety requirements specification, systematic errors. Are your field devices going to be certified to IEC 61508 or based on prior use? The standard is more forgiving of you if you base them on prior use. However, this is also some place where you can go wrong or go astray, I should say, because the latest version of ANSI ISA 61511 allows you to have a safety integrity level 2 function with 0 hardware fault tolerance. In other words, no redundancy. Well, that is based on the fact that the failure rates you're using to calculate the safety integrity level are based on prior use, but the standard doesn't state that very clearly. And, that's an unfortunate weakness, I think, in the standard, but it's a place where you have to be careful. It makes a difference in how you evaluate hardware fault tolerance, architectural constraints, whether you're basing your failure rates, are they certified devices, or are they based on prior use? Is your failure rate data reasonable? Boy, that's something that we deal with very frequently. Clients will come to us sometimes with a manufacturer's certificate that has a dangerous undetected failure rate for a device that's 1 or 2 orders of magnitude lower than what we're used to seeing even for certified devices. And sometimes it can be difficult to get the client to recognize the risk that they're taking. In the past, sometimes I have performed the calculation with their data and then with more reasonable data and showed them the difference. And like I say, you're trying to identify the risk that the client is assuming by using this potentially unreasonable failure rate that the device can't really maintain in the field. Test intervals, have people really thought through, that's one of the knobs that they want us to change is test intervals. Well, yeah, you can't, well, let's make the test interval shorter and we'll get the safety integrity level down. Well, yeah, that's true, increase it, excuse me. But is that really, if you've got a 5-year turnaround frequency and that's the only time that you can test some of your safety functions, well, yeah, just changing the number doesn't really do you anything if you can't actually operate that way. Test coverages, that's another place where people want to say, oh, our test coverage, we cover 99% of the potential failures. Well, if you look at hopefully the manufacturer's safety manual, that's possibly not reasonable. We had a good presentation, it's been some time ago, about a vendor talking about the work that has been done in the nuclear industry about what it takes to obtain proof test coverage for shutoff valves. And they're not even to get to the highest proof test coverage takes an awful lot of work and an awful lot of resources, hardware resources. Process safety time, is it accurate? Is it considered in the design? Do the valves really close fast enough? All process operating modes considered. Do you consider startup and shutdown? Are there times when one piece of equipment is out of service but not another? Will tripping this safety function at that time create a hazard you hadn't anticipated? So in summary, are 44% of the incidents in the process industries due just to a specification error of a safety function? Doubtful. Most have complex causes. Notice I'm saying serious incidents. Out of control focused attention on the specification portion of the safety life cycle, and that was a good thing. Because before that, I think most people would have said that operation and maintenance and problems with management of change were where the main causes of serious incidents were happening. And one reason for that is, well, things don't blow up during the specification stage. They have to be operating and being maintained before you have a serious incident. And so that tends to be where the focus is. That doesn't mean that the chain that led to the incident did not start back in the specification phase. So out of control, I still consider it a valuable reference.